To this semi-tutorial on NCEA Level 3 Calculus Trigonometry Internal. This will be just going over the basics in this episode, but I hope to cover the whole topic. I will be doing this topic myself in 3 weeks, so I'm hoping to do these videos to help teach myself, to then I feel that if I teach myself this and make videos, I might as well put them on YouTube and show them off to you guys, because I feel that whenever I look up videos or anything regarding NCEA, there isn't actually that much on it, as it a New Zealand based standard. But if you're not in New Zealand and you find this useful, that'd be good too. So going over the internal, hopefully you guys haven't all done it yet, but I've got it in 3 weeks. So we'll just start off with the basics today. So you would have been doing trigonometry throughout your high school careers, and we'll start off with a circle here, and you would have learnt the trig functions. So we've got ourselves a right angled triangle here with an angle there, and we'll call that theta. So you got the hypotenuse, the opposite side, and the adjacent side, right? That's all basic stuff. So then you've got sin theta, and that equals to opposite over hypotenuse, and then you've got cos theta, and then that equals to adjacent over hypotenuse, and then obviously you've got tan, sorry, thinking ahead of myself, tan theta, which equals opposite over adjacent. And you know that is SOHCAHTOA, so let's put that up quickly. SOHCAHTOA, obviously sin, sorry, man, I'm messing up my worlds already. Sin, cos, tan. Now, in this topic, there's new ratios. And these ratios are the reciprocals of these ratios. Okay, so what we have is cosecant, okay, and that is, I'm gonna draw a fancy little arrow, and that is cosec theta, and that equals 1 over sin theta. And remember, sin theta equals opposite over hypotenuse, so it's the reciprocal of that, so basically it will be hypotenuse over opposite, right? And then the same with these, but I'll just go what the other ones are called first. Then you've got secant, alright, and you've got cotangent, but I just call it cot. So then you'd have you would have sec theta and cot theta, and as you guessed, as it is a reciprocal, it is 1 over cos theta, and then 1 over tan theta. Sorry that my drawings are a bit crude, but I've only got a mouse, and it'll get better over time, I guess. So yeah, so basically, if we're going to go for the reciprocals here, so just imagine past this line as reciprocals. Obviously that would be h over a, and tan would be a over o, right? So that's just the opposites. So those are the new ratios. Pretty simple. I mean, this is the basics. It's pretty easy to grasp. And I will go into just one more thing here in this video, and that is radian measure. So let me see if I can get rid of this really easy. I don't think I can. Oh, I can wipe. There we go. Clean and simple. Now this is Sketch, by the way. Sketch Plus. I'm pretty sure it was free on the Mac App Store. It's really cool if you can just take notes and sort of annotate them how you want and stuff. So I hope you guys all got that down. Actually no, I'll undo that. So we can keep all that. We'll just keep a separate line here, and we'll just go into radian measure. Just one little basic thing that I feel that I should just put in here, as there's nowhere really else to put it. So we've got radian measure. So you have a circle, right? Another crude circle. Then you've got the center where you've got your radii, I guess you could call them, coming out. So you've got R and R, and remember the area of a circle is pi r squared, and you've got to remember these sort of things, especially pi r squared and 2 pi r, that's the circumference. You've got to remember these things for just off by heart. For NCEA, they only give you sphere, how to work out sphere volume, and things like that in the formula sheet. Obviously, this is basic stuff, but I mean, you can forget it, as I did last year, actually. But I was lucky that it was in the formula sheet. But we'll just go in here, and then see this right here is the arc length, right? So the arc obviously is an arc. It's like that. It's a curve. And this middle bit, this shaded bit, that. I'll do that again. Undo. That is called the sector. So that area in there is the sector. Now, see how I did all the. See if these are equal length, then. If the radius and arc length of the sector are the same, then the angle of the sector is 1 radian. Okay, so 1 radian. And you may be wondering what that means. Well, a pi radian is 180 degrees. So pi, in terms of degrees, because you know how there's radians and degrees, pi radian equals 180. So these are just little useful things to know. They come up in excellence problems and stuff where you get you may get say a triangle and a certain angle, and you've got to find the final answer in radians, but you may know that there may be some degrees in there that you can work out and then find into radians. So there's little things like that, and obviously 2 pi radians is the same to 360, obviously, because double pi. And that's 360 degrees. So these are pretty damn important. These are just important in general. All of the stuff is important, especially these new ratios come up a lot, and we'll be doing more with that in the next episode when we do conversion, just conversion from degrees to radians, and that's why it's important to know these little things here. So I hope you enjoyed that, guys. I hope you learned something from it. It was pretty long, just on the basics, so I'll remember to clip things down. But like, favorite, whatever you have to do. Comment if you found this good. If any constructive feedback, that'd be great. But yeah, thanks for watching, guys, and thanks. See ya.